Hello, and welcome back to the video lecture series for Introduction to the Art of Programming using Scala. We are drawing to the end of Chapter 3, and through this chapter we've been building up the basics of the Scala programming language. Now we are ready to actually put things together and work on writing our first programs. We're going to move out of the REPL and move into a script. Okay. Now, in order to understand how things are going to work in a script, you need to understand the basic way in which programs run, and this is through sequential execution. So, if I create a file called firstprogram.scala, we saw last time that we can create variables using either val or var declarations. To help illustrate the way in which sequential execution works, we'll start with the var. And as I did last time, I will set it off to be 7 to start with, and then we'll put in a print line, and we're going to say your current age is. So we're going to print out your age with a little string in front of it, and we're using the plus here to do string concatenation. Now on the next line, I'm going to change the value of age to 8. And then we're going to print it again. Now, there isn't much to this example really. But it illustrates the fact that when you run a program, at least by default, what happens is it runs one line, and then the next, and then the next, and then the next. So these 4 lines are going to execute in order, which means that we start off by creating age and giving it a value of 7, and then we print it. And when we print it here, its value is still 7. On the next line after printing it, we change its value to 8, and then we print it again, and we get the 8. So the order here is significant because age is changing values. And in a standard block of code in Scala, and we'll learn more about exactly what code blocks look like and how you can make them. Right now, all that we know how to do is create a single block of code. The code executes in exactly the order that you write it. So if we save that, and I come over here, some of you might have been wondering why I always keep 2 windows open. It's because I highly recommend you do the same, because when you start working on scripts, you want to have one that's open in VI to edit your script and another that you can run the script in. And so if we run this here, we'll see that it prints out first your current age is 7, and then now you are 8. So the order is very significant, and this is something that you need to pay attention to when you're writing your programs. You have to understand that things are going to happen in a particular order, and that particular order, at least by default, is the order in which things appear. Another thing that you might have noticed in the last video was I drew the analogy between math variables, like in algebra, and the variables that we use in programming. But you might have noticed that the variables that I used in the program weren't quite like the ones you use in math. In math, you typically use variables like x and y, or a, or I. Math variables are almost always single letters, possibly with subscripts. Programming variables are very rarely single letters. Occasionally I will use single letter variables, but they are for very specific things, and I always use the same variable for the same type of thing. More often, you want to put in a longer name, a name that says something and has meaning to you. So when you look at this says age. You have a mental idea of what an age is. I could have called this variable just a and then replaced it in every place that I'm using age with just a, But A doesn't necessarily tell you anything about what it is supposed to represent. And in math, a lot of the times the numbers don't represent things. If you go to like physics, then the numbers do represent things and they choose specific variable names like rho to be density or m to be mass. In programming, you will actually use the word mass to represent mass most of the time, because you want someone to be able to come to your program and just be able to read it and understand it. So at this point, I'm going to write a second script, and I want to play off of the example that I did last time where we were calculating how old you would be when you're 1 billion seconds old. And I guess I'll call this age in seconds dot Scala. Doesn't necessarily seem like it's going the right direction, but saying your age at a particular point in seconds is too long. So what I want to do here is start off by creating a variable, and notice it's a val. I am not intending to change this. The previous example where I showed you how a var can change and how you have to keep track of that, in some ways that's a good example of why vars can make life more complex. Once you create a val, you don't have to worry about it changing. You don't have to pay that close of attention to exactly what executes between the point where you declare it and the point where you use it. We'll see later there are some nuances to this. You can have a val refer to something, and while the val keeps referring to the same thing forever, the thing it refers to can change. We will come across that. But for now, all of the vals that we have, once they're created, they are fixed forever. So I'm going to create total seconds here, and I started off being 1 billion, as we did before. And what I want to do is I want to output roughly the number of years old you would be, the what month you are in, and then even what day in that month. You maybe even hour. We can break this down quite a bit. And to help do that and to make it more understandable, I'm going to create some other variables in here as well. So we did this last time. We did seconds in year, and that was equal to 365 times 24 times 60 times 60. Because we're going to do this with months, seconds in month. Now, once again, every month would possibly be different. You know, a month with 30 days and a month with 31 days will have different numbers of seconds in them. I'm going to ignore that for now and just say that all of our months have 30 days in them. And let's also create seconds in day, which is equal to 24 times 60 times 60. Technically, I don't need these parentheses up here, so I'll go ahead and get rid of them. Now, if you look at this, you might actually notice something. There is some duplication. And at this point, you might be fine with duplication, but hopefully especially by the end of the book, if not well before then, you should look at duplication in your code and think to yourself that it is bad. Okay? When just looking at this, while this is a fairly minor duplication, still every time you duplicate things, you have additional chances for having typos, or you have the problem that if it was messed up and you did a copy and paste, well, now you have multiple versions that you have to change. And it turns out that in this case, the expression 24 times 60 times 60, how many seconds there are in a day, is repeated in both of these others as well. So one way that I can reduce the duplication is to cut that from there. Remember, in VI you can do a cut with DD, and then paste it above. And I did a paste with a lowercase p to paste it below the line that I was on. Now that I have that, instead of saying the actual numbers, I can put that variable. And you might not think that this is a significant improvement, but it turns out that Scala can do a check to make sure that this is something we've created, that it has the right type, and therefore the only place that we can mess up the math on it is right here. If we mess up something in the variable name, for example, if I had a typo and left out an S, Scala would tell us that, it would identify it. Whereas, if this 6 had been an 8 because I had a typo in one of these, Scala is perfectly fine with an 80 instead of a 60. They're both ints, and so it would work quite nicely. So here we have our setup for, we have a total number of seconds and we have some variables to help us out. So I'm going to create a variable called years. And as we saw last time, we can get years by doing total seconds divided by seconds in year. Now I need to know how many seconds were left over after, in that year, the fractional part, the remainder, because this only gives us the whole integer quotient. So I will create another variable called seconds left in year. Once again, you'll notice that I'm using fairly long variable names here because I want someone to just be able to look at this code and read it and understand what's going on. And this is equal to total seconds. In fact, I even have a typo here. I'm going to leave that in for just a second because I want you to see what happens when I compile that. And in fact, I have another typo there. I'll leave them both in. So the first typo that I had was that I left off the S in total seconds. The second typo that I had was that I capitalized the S in seconds in year. And you can see that Scala tells us that the error here says error not found value total second. And it even shows you the line that it occurs on. It's line 7 in there. And it puts a little caret here saying, hey, this is the thing, I didn't know what it was. So inside of VI, if you're in command mode, you can hit colon and a line number. So in this case 7, and it takes me to the line. And I happen to be able to see, hey, I need an S there. I also need to replace that capital S with a lowercase s. And now I can keep going. So we've figured out how many years there are, and we've figured out how many seconds are left in that year. I'll declare a variable called month, and month is equal to seconds left in year divided by seconds in month. And then I can do seconds left in month equals seconds left in year modulo seconds in month. And lastly, the day is equal to seconds left in month divided by seconds in day. Now, one of the things about programming is every problem can be solved in many different ways. Even a problem as simple as this, where I just want to know what year, what month, and what day you're at when you turn 1 billion seconds old. And of course, once again, we're approximating here. We don't know enough yet in order to actually find the month because of the variation in lengths of months. We will be able to do that later, technically the next chapter. And then we'll learn even better ways of doing it later on. But even with this very simple problem, you could have written this in many different ways. And it's not just you could have used different variable names. You might have chosen to do fewer variables and instead have longer expressions down here with parentheses around them. A lot of those things are style issues, and some styles are superior to others. But early on, one of the main things that you want to learn is just how to structure the logic. So much of the challenge in programming is about learning how to take the logic that you think on a daily basis and structure it into a rigorous way so that you can put it into a programming language. So at this point now I could do a print line and say you will turn total seconds at years, comma, month plus months. And actually, well, after that plus, I can go ahead and hit enter and indent a little bit. Days, oops, day plus days. Now, let's see if I typed everything in correctly. There we go. It says you will turn 1 billion seconds. Oh, I left out seconds. And I can change where I have that. I used the Shift J to join lines. That was probably one of those commands where when it was first introduced, you were like, why would that matter? So as a rough average, you turn 1 billion seconds old when you are 31 years, 8 months, and 19 days. So late in August of your 31st year, you will turn 1 billion seconds old. I find that to be a remarkable statistic, just because if you think about the number of, for example, the number of people in the world, or anyone who's a billionaire, if, for example, you were born and someone came up and shook your hand every second and they just moved you around, so when you were young, they carried you, as you got older, you walked, and every second you shook a new person's hand, you would not get through the Americas. You would still be shaking hands you would have finished, I guess, North America. Actually, probably wouldn't be finished with North America quite at 31 years. You would never finish shaking everyone's hand in the world. There are more people in the world than you will live number of seconds. And so, while that's not really all that significant here, the programming language gives you the ability to kind of express this and to look at this. And so this is our first example of a little program. In the next lecture, we'll come back and we will make it more useful to us.